Welcome to the Math Record. Today we'll be learning about the binomial theorem. This video will cover part 3 of chapter 6 in our precalculus class. So what is the binomial theorem? Well, you can spell it, say like this, B-I-N-O-M-I-A-L, theorem, which also be within the title. So the binomial theorem is a method to find a pattern when terms are raised to a power. So imagine you have something like 2x minus 3y raised to a power of 4. Raised to a power of 4. This would be too much work if you had to do this by hand. So you have like 2x minus 3y times 2x minus 3y. And you have this like 2 more times basically. And it's going to just take too much work. And it takes too much time. The binomial theorem will help us get this. So basically, let's have something like, there's usually only going to be 2 terms. There's only 2 terms basically. So you have something called, so you have the first term basically, plus the second term, raised to a power, which I'll call p. So basically, it's going to be in the form, the summation of x is equal, sorry, not x. I don't want to use x because usually the first term and the second term uses the variables x and y, or like y and x, I don't care what way. But basically, we're just going to use a. A is equal to 0. A does not really, A could be like anything, it could be A, B, C, D. I just don't, or it could be like X and Y. It's just that like, I don't want to use X and Y just so then you won't understand like, you could keep track of the variables. So, and then you have up to the power basically. Okay. And then you have you're basically using some, using factorials. So you have p factorial all over a factorial and p minus a factorial times the first term in the parentheses raised to the power minus a times the second term raised to the power of a. So that's basically the general form of the binomial theorem. So a factorial would be like, it's going to be a natural number. So if you have like 1 factorial is equal to 1, 2 factorial will equal to 1 times 2, 1 times 2. And then you have 3 factorial, which is equal to 1 times 2 times 3. 4 factorial is equal to 1 times 2 times 3 times 4. And 5 factorial will be like 1 times 2 times 3 times 4 times 5. So you see how the pattern is going basically? So basically this is how you're going to use factorials. So this is the general form of how we're going to be using it. So if you want to like take this down as a note now, you could, or you could just go back to the video. Okay. Now let's like use an example. The example we had before, let's have 2x minus 3y is to the power of 4. So we're going to write the summation down first. So the summation, we have a is equal to 0, all the way to the power of 4, because that's the maximum amount right here, 4. And then you have 4 factorial, all over a factorial, sorry, times 4 minus a factorial, times 2x, because that's the first term, to power of a, 4 minus a, times negative 3y, to power of a. So the first term would be when a is equal to 0, okay? So you have to find when a is equal to 0. So basically, when a is equal to 0, you have 4 factorial, all over 0 factorial, times 4 minus a, so a is 0, so that makes 4 factorial, times 2x to the power of 4 minus a, where a is 0, that makes 4. So that's 2x to the power of 4, times negative 3 to y to the power of 0, basically. So if it's 4 factorial over 0 or 4 factorial, the first term of this will always be equal to 0. So even if it's 5 factorial over 0 factorial 5 factorial, it's equal to 1. Or like 6 factorial over 6 factorial times 0 factorial is also equal to 1. So this case will always be 1, basically. So this is 1 times 2x to the power of 4. To the power of 4 is 16 x fourth, right? And then a negative 3y in parentheses to the power of 0 is just 1. So the first term is 16x to the power of 4. Okay? So that's our first term. I'll write it on the bottom so you get the terms out. So 16x to the power of 4. Okay, the next term will be when a is equal to 0. Because this case gets us when a is equal to, a is equal to 0. The next term is when a is equal to 1. So then we have to do a is equal to 1, a is equal to 2, a is equal to 3, and a is equal to 4. So basically we're just going to use the entire thing. Because this will be the summation. So when a is equal to 0, plus when a is equal to 1, plus when a is equal to 2, plus a is equal to 3, plus a is equal to 4. So that's basically what we're going to be doing the entire time. So now we have to find when a is equal to 1. So we have 4 factorial all over 1 factorial over 4 minus a, which is 3 factorial, times 2x to the power of 4 minus 1, which is 3, and negative 3 to the power of 1. So now we have 4 factorial, which is just 4 times 3 times 2 times 1, all over 3 times 2 times 1, and 1 factorial is just 1. So these numbers kind of cancel with these numbers, so you have 4 left, basically. You can also use your calculator for this. So you have 4 factorial. 4 times 2 to the power 2x to the power of 3 is just 8x cubed times negative 3 to the power negative 3y to the power of 1 is just negative 3y. So you get 4 times 8 times negative 3, which gets you negative 96 x cubed times y. So that's your next term, negative 96 x cubed x cubed y. So delete this. So that's our second term. So let's write that down. Negative 96 x cubed to the y. And then we have when a is equal to 2 now, basically. So now we have 4 factorial over 2 factorial over 2 factorial times 2x to the power of 2 times negative 3y to the power of 2. So now 4 factorial over 2 factorial over 2 factorial. So 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. So these numbers cancel with this one. And the 2 here could take out the 2 from here. So 4 divided by 2 is 2. So 3 times 2 is 6. So the first number is 6. So you have 6 times 2x to the power 2 is 4x squared, times negative 3y to the power of 2 is 9y squared. So 6 times 4 times 9 is 6 times 4 times 9 is 216 plus 216x squared y squared, basically. Sorry, that's too big, and I want to save room. Okay. So we have plus 216x squared y squared. And now we have to find when a is equal to 3, basically. So a is equal to 3, 4 factorial, 3 factorial, and 1 factorial times 2x to the power of 1 times negative 3y to the power of 3. So now you have 4 times 3 times 2 times 1 times 3 times 2 times 1 times 1. This number cancel out with this number. And 4 divided by 1 is just 4. So basically, you're going to have 4 times 2x to the power 1 is just 2x. And negative 3y to the power of 3 is just negative 27y cubed. So 4 times 2 times 27 is negative 216. So we have negative 216 xy cubed. basically. So it'll be negative 216 times x times y cubed. So delete this. So negative 216 x y cubed. And now we have the last term when a is equal to 4. So that'll be 4 factorial all over 4 factorial, 0 factorial, times 2, 2x to the power of 0 times negative 3y to the power of 4. So as I said before, if there's a 4 factorial, 4 factorial, 0 factorial, it's always going to equal 1, basically. Even if it's 5 factorial over 5 factorial times 0 factorial, it's 1. So if you ever see a 0, it's probably just going to be 1. So this is 1. 2x to the power of 1 is 1. And negative 3y to the power of 4 is just 81 y to the 4th. So it's basically that simple. So we have 81 y to the 4th plus 81 y to the 4th. So instead of doing all the math to like multiply and like distribute out, now you could use the binomial theorem, and this would be your entire factor out form. And you can always see like this kind of trend. So you have like the first term, x to the 4, because like x power of 4. And now you have to put them in combination. So you have x to the 3 times a y, because this one has to be 1, right? So it's y to 1 and this x to 1. So 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and x is 0 plus y to the 4th is just 4. So it's 4, 4. So it's always 4. You see how that works? So these are the combinations of how it works. So you have an x to the 4 term, x3 times 1 x to the y term, and then x squared times y squared, and then x to y squared. So this one's you see the x term is decreasing by 1 every single time. So it's x to the 4, x to the 3, x to the 2, x to the 1, and then there's no x's. And then that while the y term is increasing, so it's y to the 0 because there's nothing, and then y to a 1, then y to a 2, then y to a 3, then y to a 4. So it kind of just follows this trend, except now you use the equation basically to find the coefficient. So you get like the 16, the negative 96, the 216, the negative 216, and the 81. So basically, if you have 4 terms, if you just raise to a power of 4, basically, then you're going to have 5 terms. So you have 1, 2, 3, 4, 5. If you have raised to a power of 5, you're going to have 6 terms. You have raised to a power of 6, you have 7 terms. See how that works? Because you're going to have the individual terms and then the combination. So it's usually one more than the power. So basically, that's what you're going to do. You just got to do this binomial theorem like a bunch of times. You just got to plug in when a is equal to like 1, when a is equal to 1. Sorry. When a is equal to 1, 2, 3, 4, 5, up to the power, basically. And then you're going to get all these numbers. So if they ever ask you how to factor this out, just use the binomial theorem. Okay? And we could delete all this. Another question they might ask during these type of these questions is looking for a specific coefficient. So basically, let's say they want you to find the second term, like, sorry, they want you to find the coefficient of the second term, basically. The first term is always when a is equal to 0. So if you put like a is equal to 2 as the second coefficient because you think the 2 means the second, it's not. It's 1 minus that 1. So if a to the 0 is the first term, a to the first is the second term, and a to the first is the first term, a to the second is the second, a to the first is the second term, and a to the second is the third term. So if you're looking for the nth term, basically just minus 1 from it to get a, basically. So that's what you're going to do. So you want to look for the second term, you got to actually look for when a is equal to 1. So let's say that you want to find the coefficient of the second term, right? So basically you only do this like one time. So you want the second term because you want to waste your time like finding like the third term, the fourth term, the fifth term, the first term, like it doesn't matter. So you want the second term, plug in where a is equal to 0, you have 4 factorial over 1 factorial over 3 factorial times 2x to the power of 3 times negative 3y1. So 4 factorial over 1 factorial over 3 factorial is just 4. And 2x to the power of 3 is 8x cubed. So, and then you have something like negative times negative 3y. So you have 4 times 8 times 3. I mean 4 times 8 times negative 3, which gets you negative 96 x cubed y. So the third term is the coefficient of the second term would be the negative 96 x cubed times y. Usually they don't say second term, third term, first term because it's kind of different. Because they're all kind of considered a term, but you can't like tell which one is determined as which kind of term. So this won't technically be counted as a second term. But I'm using this as an example. So what they would usually ask is that they want the coefficient of the like x x squared term times y squared term, basically. So you have to find out when this is equal to each other. So basically what you do is that when you see this, you kind of just look at like one part. So if but usually they're gonna work. So make sure that the powers that you add together has to be the same. So 2 plus 2 is 4, right? And this power to 4. Okay, so this makes sense. Because if they say something like x to the power of 3 times y squared, and 3 plus 2 is 5, right? But 5 is not equal to 4, because it's not equal to the power, so this is never possible. So the coefficient of this is possible. So we need to find when x is squared. So basically what you're going to do is that you see something like here, right? You kind of want to ignore the 2. So you have x to the power of 4 minus a is equal to x squared, right? So a has to just equal to 2. So that's how you find it, basically. You really don't want to care. Or you could, if you want to just focus, if you want to focus on the x squared term, the first coefficient, or now if you want to focus on the y squared term, so instead you could just have, the only way to get the y squared term is right here. So now you're going to have negative 3y to the power. I mean, you could ignore the negative 3 as the same case how I ignore 2 here. You have y to the power of a is equal to y squared. And you still get a is equal to 2. So that's 2 ways to just get the number. You only need to do it once. So then let's say you just use the first way. You said x 4 minus a equals to x squared. So a is equal to 2, right? So now you just have to plug 2 into the summation. So when a is equal to 2, you put 4 factorial over 2 factorial over 4 minus 2 factorial, which is 2 factorial, times 2x to the power of 4 minus 2, which is 2, times negative 3y to the power of 2. So this will get you 6 times 4x squared times 9y squared. So now when you multiply this together, you get the x squared times y squared term, which what you get. So the coefficient of that term is basically 6 times 4 times 9, which is 216. So that's all you write. The coefficient of the x squared y squared term is 216. And that's usually how you like solve these type of questions. So if you just understand the general form of how to write the binomial theorem, you should be fine. Um, that basically covers everything for the binomial theorem. Thanks for watching, and I'll see you at the next math record.